Okay, now we're going to talk on organ transplants. As you can see, there are 4 types of organ transplants. Now, before we start, when you're doing an organ transplant, what are you matching for? What are you trying to find the donor to be? You're trying to match up as best as can the MHC. The MHC, remember that's called Major Histocompatibility Complex, histocompatible. So when they're looking for a donor on the donor list, that's really what you're looking mainly for, the MHC. Now, it would also be nice if you could get similar blood type. The reason is when you're doing a transplant, you take it out and then you clean it during surgery, and you try to get all the red blood cells out and everything like that, but sometimes you don't. So you'd like, so the main thing is the MHC, but you'd also, if you could, get a similarity of the blood typing to red blood cell typing. Okay. Now, the 4 types of organ transplants you have, as you can see, the autografts. That's where you take from one part of your body and put it in another. So let's say you're doing a rhinoplasty, which is a nose job, and you want to straighten the nose. You take a little cartilage from someplace else, generally behind the ear, take some of that cartilage and then place it in the nose, which we'll call a columella. Another is an isograft, which is identical twins. Okay, the allograft is between individuals of the same species. Individuals, that mean one human, let's say, to another. And then the xeno is from an animal. Oftentimes in heart valves, they used to use the porcine valves, which are the pig valves for heart valves that had a problem. Now, prevention of rejection. Rejection is a bit, now, first of all, no matter if you're coming from yourself to yourself, you will have inflammation. Sometimes inflammation can be so bad you even have to take the autograft out. We go to prevention of rejection. These are some, really what you're trying to do is to immunosuppress. You're also trying to suppress some of the inflammation with the corticosteroids. Remember, those are the steroidal anti-inflammatory drugs. The NSAIDs are not powerful enough to do that in a transplant. You're using anti-proliferative drugs. These are the same drugs you use in cancer treatment. Immunosuppressant drugs. Glucocorticoids, antibodies to try to reject targeted monoclonal antibodies. These antibodies would be trying to attack your own antibodies. So these are some of the, but when we come to it, even with all of that, about 50% of transplants are rejected in 10 years. Now, of course, you have far better success if we're talking about autografts and some isografts, but now, when it comes to, let's say, bone marrow transplant, you could use the chimera. Chimera is kind of like 2 people in one, in a way. And you would douse the bone marrow out and then put new bone marrow in and try to make the immune system like the donor system, to say it another way. Okay, so we go further. I won't get into chimera. Our next is immunodeficiencies. Okay. We have congenital and acquired immunodeficiencies. Now, congenital, what does that word mean? It means at birth, but it doesn't mean necessarily genetic. It means at birth. So if a person was delivered bad and had a shoulder problem coming out of the uterus, that would be a congenital problem, but it would not be genetic. So congenital just simply means at birth. Okay, so we have congenital and acquired. Congenital would be at birth. Okay, one is, this is a congenital, the severe combined immunodeficiency syndrome, SCID. Now that's a rough one because you have a genetic defect in that case, and you have a marked deficit in in all of your third line, B and T cells. You pretty much from that point on are going to have to live in an isolation or a very protective immune environment. And one thing that can do it is defective adenosine deaminase. But if untreated, it can lead to death. The most common is this gentleman here. You may have heard of the bubble boy. He lived in Tomball, David Vetter, he had the severe combined and had to live, and finally they took a chance on a transplant of immune from his sister, I believe, and then he still couldn't make it because of an infection that occurred in the transplant. Hodgkin's disease, which is called Hodgkin's lymphoma, is a B cell problem, cancer of B cells. Now remember, in cancer you make a lot of cells, but they don't work. You make a lot of cells, but they don't work. And so what will happen in cancer, these cells are multiplying very rapidly in the bone marrow, and they're crowding out the good cells. So you're having a lot of B cells, but ones that don't work. And this is what we call the Hodgkin's lymphoma. Now we have Hodgkin's and non-Hodgkin's lymphoma. Then we come to AIDS. AIDS takes out the T4 cells. Now, I'm not going to get heavy into AIDS. You'll learn it in microbiology. But I also, if you look at my website, I have a AIDS PowerPoint. I'm not going to do that since this is not face-to-face. But AIDS is very debilitating. It takes out the T4 cells. Now, remember, your immune system also protects against cancer. So individuals that have AIDS, which kind of eliminates the T cell system, will have a higher increase in certain tumor conditions like Kaposi's sarcoma, which is a condition of the skin cell and connective tissue blood vessels. You opened up to opportunistic infections, a lot of weight loss, caused by the human immunodeficiency virus, and you can read on that in my PowerPoint section if you'd like. Okay, so that's AIDS there. Since AIDS cannot be treated, you hit, a chain is only as strong as its weakest link, and if you read my AIDS PowerPoint, you'll see you have to hit it with several therapies at the same time. You're trying to attack all the weak links in that. And first of all, the AIDS virus has to attach to your cell. So you try to block it there. It attaches to cells that have C4 receptors, which the T helper cell has the most. So you can block it there. Then a virus has to internally transcribe. You can block it there. So there are several areas you attempt to block it at the same time. Okay. Now we go to autoimmune diseases. Autoimmune diseases are situations in which you fight yourself. There are many different autoimmune conditions: multiple sclerosis, myasthenia gravis, which is a muscle weakening, Graves' disease, type 1 diabetes, which is also called juvenile onset. Okay. What do we think went wrong in autoimmune? Well, remember, you develop tolerance early in your life. You develop tolerance early in your life. That was part of the education process. So what could possibly go wrong to then cause autoimmune? Well, one thing that can happen is you develop tolerance to certain things, okay? Sometimes foreign antigens may resemble self-antigens. Foreign antigens may resemble. So what could happen is, after tolerance has been formed, a foreign antigen gets in. You attack the foreign antigen, produce antibodies, protect. But some of your surface antigens on cells look so similar after you've done this that it turns and attacks that. One example of this is the group A streptococcus. The group A streptococcus. It may resemble isoantigens, that's your natural antigens, on some heart, generally heart valves, joint skin. The joints could lead to what we call rheumatoid arthritis. You could, the heart valves could lead what we call rheumatic heart disease. So in other words, foreign antigen gets in, looks like some of yourself, and the immune system mistakes it. That's one possibility. Another possibility is when you were developing tolerance, you were developing tolerance to those things that the immune system could see and develop tolerance. Now, where couldn't it see? It couldn't see underneath the blood-brain barrier. It couldn't see inside cells. So you had some areas in the body that it could not look at and develop tolerance to. So let's say you had a bad car accident, shook up the blood-brain barrier. These antigens come out from underneath that the immune system never saw, and it starts attacking it. So that's another possibility. Okay? Right here, novel antigens. Remember, you had epigenetics. That means you change your genetics as you live. Perhaps you may have changed some stuff that you didn't never develop tolerance to, and so all of a sudden now it's attacking these new antigens that you would have in you, because all of a sudden now this has been, let's say you're 30 and you do epigenetics and create something the body never develops tolerance to. So there are many theories as to that. Here are some conditions that are autoimmune. Multiple sclerosis, destruction of myelin. This is an attack on the myelin sheath. Guillain-Barré syndrome of peripheral nerves, generally both autonomic and somatic. Myasthenia gravis, you are actually attacking acetylcholine receptors in, for skeletal muscle. Remember, skeletal muscle has receptors for acetylcholine. Graves' disease is a thyroid condition. Type 1 diabetes. So I'm just naming a few conditions that are autoimmune. Treatments, anti-inflammatory drugs, antibody against cell adhesion molecules. So we have different plasmapheresis where you clean antibodies from the plasma. So there are various treatments. Okay, I won't get into tumor necrosis. So that then brings us to hypersensitivities, which I will do in another video.